Bethlehem Steel was once one of the most powerful industrial institutions in American history. Founded in the late 19th century and rising to dominance in the early 20th, the company became a cornerstone of U.S. infrastructure, military production, and economic expansion. From bridges and railroads to warships and skyscrapers, Bethlehem Steel supplied the material backbone of a growing nation. At its peak, it employed tens of thousands of workers and operated with an authority that extended well beyond the factory gates, shaping the city of Bethlehem, Pennsylvania, and influencing national policy during wartime and peace. Yet despite its scale and influence, Bethlehem Steel did not collapse suddenly, nor was it destroyed by a single disaster or market shock. Its decline was gradual, structural, and rooted in decisions made at the highest levels of control. Decisions about leadership, investment, technology, and the belief that size itself could protect an institution from change. By the time steel production at the Bethlehem plant ended in 1995, the outcome had already been determined years earlier. The company would file for bankruptcy in 2001 and be dissolved in 2003, marking the end of a century-long industrial reign. This documentary examines how one of America's greatest steel producers rose to power, how it maintained control for decades, and how the same system that built its strength ultimately ensured its failure. To understand the fall of Bethlehem Steel, the story must begin with those who controlled it. Chapter 1. The Men Behind Bethlehem Steel. Charles Michael Schwab was born in 1862 in Williamsburg, Pennsylvania, a small town in the Appalachian region where coal, railroads, and steel were already beginning to alter daily life. His parents were German immigrants with limited means. Schwab did not inherit wealth, influence, or technical expertise. What he inherited instead was proximity. Proximity to an industry that was quietly becoming the backbone of the United States. Schwab's early education was uneven. He attended college briefly, but did not complete a degree. Unlike many industrial leaders of his era, he was not trained as an engineer, a metallurgist, or a craftsman. His entry into the steel industry came through clerical work. He joined Carnegie Steel in a junior administrative role, responsible for paperwork, correspondence, and internal coordination. This position would define his entire career. From his desk, Schwab observed how steel was managed rather than how it was made. He saw production summarized into numbers, schedules translated into reports, and human labor reduced into costs and output. He learned that control did not require physical presence. It required information, timing, and alignment with those who held capital. Andrew Carnegie recognized this immediately. Schwab had a rare ability to simplify complexity and communicate it upward. He spoke the language of executives fluently, anticipating concerns before they were expressed. His rise within Carnegie Steel was rapid, not because he knew steel better than others, but because he understood how power flowed through the organization. By his early 30s, Schwab was no longer an assistant. He was involved in strategic discussions, corporate negotiations, and long-term planning. He learned how mergers were structured, how competitors were neutralized, and how scale could be used as a weapon. Steel, in Schwab's view, was not merely a product. It was leverage. Whoever controlled steel controlled transportation, construction, and national growth. In 1901, when Carnegie Steel was absorbed into the newly formed United States Steel Corporation, Schwab became its first president. At the time, U.S. Steel was the largest corporation in the world. It represented a new model of industrial power, centralized, vertically integrated, and deeply entangled with finance and government. Schwab now stood at the center of American industry. He dealt directly with bankers, investors, and political figures. His role was no longer operational. It was managerial and symbolic. He represented stability, coordination, and authority. But his time at U.S. Steel also revealed limits. The corporation was vast, cautious, And constrained by financial oversight, Schwab clashed with powerful investors, including J.P. Morgan Circle, over control and strategy. In 1903, he resigned. His departure was not a failure. It was a transition. Schwab left U.S. Steel with something far more valuable than a title, a complete understanding of how large industrial empires functioned and how they resisted change. He had seen how decisions were slowed by bureaucracy, how innovation was often sacrificed for predictability, and how leadership prioritized the scale over flexibility. When Schwab later took control of Bethlehem Steel, he brought these lessons with him. Bethlehem Steel was smaller, less centralized, and far less influential than U.S. Steel at the time. But under Schwab, it adopted a familiar structure. Authority concentrated at the top, decision-making removed from daily operations, and long-term strength measured by expansion and dominance rather than adaptability. Schwab did not manage Bethlehem Steel as an inventor or reformer. He managed it as an executive shaped by consolidation. His leadership emphasized order, hierarchy, and continuity. Those who advanced within the company were those who aligned with this vision. Bethlehem Steel's identity, therefore, was not formed first by its furnaces or its output, but by its leadership philosophy. The company inherited a worldview forged in boardrooms, not workshops. One that believed industrial power was secured through control, not experimentation. This culture did not emerge suddenly. It developed quietly, reinforced by success, and rarely questioned during years of growth. By the time Bethlehem Steel would face a changing global industry, its leadership assumptions were already deeply embedded. The men behind Bethlehem Steel believed in strength through size, stability through authority, and security through central control. These beliefs would propel the company upward, and later make it dangerously slow to change. Chapter 2. Why Bethlehem, Pennsylvania? Bethlehem, Pennsylvania was selected as the location for Bethlehem Steel because its geographic characteristics match the operational needs of heavy industry during the late 19th century. The town is situated in the Lehigh Valley, a natural lowland corridor in eastern Pennsylvania. This valley provided a stable physical environment for large-scale industrial construction. The terrain was relatively even, the land continuous, and the surrounding area free from major natural obstacles that would limit expansion. For industrial planners, this reduced construction complexity and long-term spatial risk. A defining feature of the location was the Lehigh River. The river runs directly through the valley and provided a dependable means of moving large volumes of material. In an era when overland transport was slow and expensive, access to a navigable river significantly lowered logistical costs. Raw materials could be delivered in bulk, and finished steel could be moved out without excessive handling. The river's importance was functional. It required no new infrastructure to operate an integrated Bethlehem into existing commercial movement patterns. This allowed steel operations to scale without relying on untested transport solutions. Bethlehem's position also placed it within efficient reach of key natural resources. Pennsylvania was a major source of anthracite coal, an energy resource critical to industrial operations at the time. Coal fields lay within practical distance of the Lehigh Valley, allowing fuel to be delivered consistently and at manageable cost. Proximity without direct placement inside mining regions was an advantage. Mining areas were often constrained by terrain and subject to instability. Bethlehem avoided these constraints while maintaining access to energy supply. This separation allowed energy to remain an input rather than a limiting factor. Iron ore supply followed the same logic. The site was not chosen because ore deposits existed beneath it, but because ore could be transported reliably from multiple sources. Industrial planning prioritized consistent access over immediate proximity. Bethlehem's location supported predictable delivery without dependence on a single origin. Rail infrastructure complemented these geographic advantages. By the time Bethlehem Steel expanded, the town was already connected to regional rail lines serving major northeastern markets and inland industrial areas. These connections supported material inflow and product distribution without isolating the site or over-concentrating traffic through a single route. This integration placed Bethlehem within an established industrial network, rather than at its edge. Land availability further reinforced the decision. Steel production requires extensive space for facilities, storage, and supporting infrastructure. The Lehigh Valley offered sufficient land for initial construction and future expansion. The geography allowed growth to occur incrementally, aligning capital investment with production demand. This reduced the likelihood of relocation or redesign as operations expanded. Many industrial sites became constrained by their surroundings. Bethlehem did not. The town's position relative to major population centers also contributed to its suitability. Bethlehem was close enough to supply large urban markets efficiently while remaining outside high-cost metropolitan areas. This balance allowed production to operate at scale without incurring the expenses associated with dense urban environments. From an operational standpoint, the location minimized uncertainty. Transportation access existed. Resource supply was reachable. Space for expansion was available. These conditions reduced planning risk and supported long-term industrial use. The selection of Bethlehem was not experimental. It followed established industrial logic based on efficiency, access, and control. The location required adaptation neither from geography nor from infrastructure. It functioned within the constraints and expectations of its time. In geographic terms, Bethlehem, Pennsylvania provided a practical solution to the fundamental requirements of steel production: stable land, access to energy, material movement, and room to grow. That combination explains why it was chosen. Chapter 3. From Iron to Steel. Bethlehem Steel emerged from a deliberate transition rather than a sudden invention. The company's origins lay in iron production, but its long-term direction was defined by the decision to move into steel at an industrial scale. In the mid to late 19th century, iron remained the dominant structural metal in the United States. It was widely used for rails, bridges, and machinery, but it had clear limitations. Iron lacked the strength, durability, and consistency required for larger structures and heavier loads. As American infrastructure expanded, these limitations became increasingly apparent. Steel offered a solution. Compared to iron, steel provided greater tensile strength, improved durability, and more predictable performance under stress. These qualities made it suitable for emerging demands in construction, transportation, and later military applications. The shift from iron to steel was not optional for companies seeking long-term relevance. It was a necessary adaptation to changing industrial requirements. Bethlehem's transition began with incremental changes rather than immediate transformation. Early operations focused on iron production while gradually incorporating steel-making processes. This approach reduced risk and allowed existing facilities to be adapted rather than replaced outright. Central to this transition were blast furnaces. Blast furnace technology was already well established, but its application at Bethlehem required scaling and refinement. These furnaces enabled the continuous production of molten metal by forcing air through layers of iron ore, coke, and limestone. The process allowed for higher temperatures and greater output than earlier methods. Operating blast furnaces demanded precision and coordination. Temperature control, material ratios, and airflow directly affected metal quality. Early steel production was therefore as much a matter of process discipline as technological capability. Bethlehem invested in furnace capacity and operational consistency rather than experimental design. As steel-making methods advanced, Bethlehem incorporated open hearth furnaces, which allowed greater control over composition and quality. Unlike earlier techniques, open hearth processes enabled operators to adjust chemical content during production. This made it possible to produce steel suitable for a wider range of applications. The adoption of these technologies marked Bethlehem's transition from a regional iron producer to an emerging steel manufacturer. The shift was gradual, but decisive. Production lines were reorganized around steel output, and capital investment increasingly favored steel-focused infrastructure. Expansion followed demand. As steel consumption increased across the United States, Bethlehem responded by enlarging its production capacity. Additional furnaces were built. Supporting facilities such as rolling mills and finishing operations were added to process raw steel into usable forms. This integration allowed Bethlehem to control more stages of production and reduce dependence on external suppliers. Scale became a strategic objective. Larger furnaces meant higher output per cycle. Continuous operation reduced downtime and improved efficiency. Over time, Bethlehem's facilities were structured to support sustained, high-volume production, rather than small-batch output. This expansion was not driven by innovation alone. It reflected confidence in steel as the dominant industrial material of the future. Infrastructure projects increasingly specified steel over iron. Railroads required stronger rails. Urban construction demanded materials capable of supporting greater height and weight. Bethlehem aligned its production capacity with these requirements. The transition from iron to steel also changed the internal organization of the plant. Steel production required tighter coordination between departments, standardized procedures, and consistent quality control. Processes were formalized. Output was measured and categorized. Variability was reduced wherever possible. By the early 20th century, Bethlehem had completed its transformation. Iron production no longer defined the company's identity. Steel did. Facilities were designed around steel output, and expansion plans assumed continued growth in steel demand. This transition established the foundation for Bethlehem Steel's rise. The company's later prominence rested on decisions made during this period. Decisions focused on adopting proven steel technologies, scaling production capacity, and aligning output with national industrial needs. Bethlehem did not invent steelmaking, nor did it lead technological experimentation. Its strength lay in implementation. The company adopted existing methods, applied them at scale, and organized production around consistency and volume. From iron to steel, the shift was deliberate, structured, and permanent. By committing fully to steel production, Bethlehem positioned itself for decades of expansion in an economy increasingly built from steel. Chapter 4. Building a Nation? At its civilian peak, Bethlehem Steel was no longer defined by the size of its furnaces or the number of workers passing through its gates each day. Its true presence was visible hundreds, sometimes thousands of miles away, embedded in structures that reshaped how Americans moved, lived, and built. Steel leaving Bethlehem did not remain an industrial product for long. It became bridges that spanned rivers, rails that stitched regions together, and frames that allowed cities to rise vertically for the first time in history. One of the most prominent examples of Bethlehem Steel's civilian impact was its role in major bridge construction during the early 20th century. The George Washington Bridge, completed in 1931, relied heavily on Bethlehem Steel's high-strength structural components. At the time of its opening, it was the longest suspension bridge span in the world. Its scale pushed engineering limits, requiring steel that could tolerate extreme tensile stress while maintaining long-term structural stability. The bridge stood not as a monument to a company, but as proof that American steelmaking had reached a level of precision and reliability unmatched elsewhere. Rail infrastructure represented another critical area where Bethlehem Steel became indispensable. As railroads expanded across the United States, demand grew for steel rails capable of carrying heavier locomotives and larger freight volumes. Bethlehem Steel supplied rails, beams, and fasteners to major rail operators, supporting networks that moved coal from Appalachia, grain from the Midwest, and manufactured goods between coastal cities. These rail lines were not symbolic projects. They were economic arteries. Their durability depended on steel that could endure constant friction, vibration, and seasonal temperature extremes without rapid failure. The rise of American skyscrapers further demonstrated Bethlehem Steel's central role in civilian construction. In cities such as New York and Chicago, traditional masonry buildings reached their practical limits. Steel frame construction offered a solution. Bethlehem Steel supplied structural steel for numerous high-rise projects, enabling architects to design taller buildings with open interior layouts and expansive windows. Steel skeletons replaced load-bearing walls, allowing cities to grow upward rather than outward. This shift permanently altered urban density and land use in America's largest metropolitan areas. Beyond iconic landmarks, Bethlehem Steel's materials were embedded in less visible but equally important structures. Factories, warehouses, power stations, and municipal buildings across the country relied on standardized steel sections produced at scale. These structures supported manufacturing, electricity generation, public services, and transportation hubs. While they rarely appeared in newspapers or postcards, they formed the physical framework of everyday American life during the industrial century. Bethlehem Steel's ability to dominate civilian construction was not solely a matter of quality, but of capacity. The company could deliver large volumes of steel on tight schedules, an advantage that made it a preferred supplier for national projects with strict deadlines. Its integration of production, finishing, and distribution allowed builders and engineers to rely on consistent specifications across multiple sites. This reliability reduced uncertainty in large-scale construction and encouraged more ambitious designs. By the mid-20th century, Bethlehem Steel had become synonymous with structural steel itself. Engineers specified its products not because of branding, but because of familiarity and trust built over decades of performance. Bridges stood, rails endured, and buildings remained upright, reinforcing the company's reputation through use rather than advertisement. This era represented a moment when Bethlehem Steel's output aligned perfectly with national demand. The United States was expanding its infrastructure, modernizing its cities, and connecting distant regions into a single economic system. Steel was the material that made this transformation possible, and Bethlehem Steel was one of its most consistent suppliers. Its civilian production did not seek attention, yet it shaped the visible world more permanently than most institutions of its time. The steel produced during these years outlasted the company itself. Long after furnaces cooled and payrolls disappeared, bridges continued to carry traffic, buildings continued to house businesses, and rail lines continued to support commerce. The presence of Bethlehem Steel remained embedded in the landscape, not as a story, but as a physical fact, silent, load-bearing, and unavoidable. Chapter 5. Steel at War. When the United States entered the First World War, Bethlehem Steel was no longer simply a civilian supplier of construction material. It became a strategic industrial asset. War transformed steel from an economic commodity into a military necessity, and Bethlehem was positioned to respond faster and at a larger scale than nearly any other producer in the country. During World War I, Bethlehem Steel redirected a significant portion of its capacity toward armaments production. Its plants manufactured artillery shells, armor plate, and heavy structural components used in naval construction. Steel output was no longer measured only in tons, but in battlefield utility. Every specification was dictated by military standards. Tensile strength, impact resistance, and uniformity became matters of national security rather than engineering preference. The interwar period did not diminish this capability. Instead, it refined it. Bethlehem Steel invested in processes that allowed faster conversion between civilian and military production, an advantage that became decisive when the United States entered World War II. By the early 1940s, the company was fully integrated into the American war economy. World War II marked the absolute peak of Bethlehem Steel's power and output. The company became one of the largest suppliers of steel for shipbuilding in the United States. Its steel was used extensively in the construction of battleships, aircraft carriers, destroyers, and transport vessels. Naval armor plate produced by Bethlehem protected hulls against torpedoes and artillery fire, while structural beams formed the internal skeletons of ships assembled at coastal shipyards. Weapons production expanded in parallel. Bethlehem Steel manufactured gun barrels, shell casings, and heavy-caliber components required for tanks and artillery systems. These were not mass-produced consumer goods. They demanded precision under extreme conditions. Each failure carried the risk of loss in combat, placing immense pressure on quality control and inspection. The margin for error narrowed, but production volume increased. To meet wartime demand, Bethlehem Steel operated continuously. Furnaces burned without interruption, and rolling mills ran day and night. Shifts overlapped, creating a constant flow of workers entering and leaving the plant at all hours. The concept of a workday effectively disappeared. Time inside the factory was measured by production targets rather than clocks. Labor shortages reshaped the workforce. Women entered industrial roles in large numbers, filling positions previously reserved for men who had left for military service. Training programs were accelerated, and specialization intensified. Workers often performed a single task repeatedly, contributing to efficiency but also physical strain. Accidents increased as fatigue became unavoidable in a non-stop production environment. Logistics became as critical as manufacturing itself. Steel produced in Bethlehem had to reach shipyards and armories across the country on precise schedules. Rail shipments were prioritized under wartime controls, and coordination between government agencies and private industry tightened. Delays were not inconveniences. They were potential operational failures. The scale of output during World War II was unprecedented. Bethlehem Steel produced millions of tons of steel specifically allocated for military use. Its contribution was not symbolic or secondary. Without this level of industrial capacity, the United States would have struggled to sustain prolonged naval operations and large-scale mechanized warfare. At the height of the war, Bethlehem Steel's identity was inseparable from the national effort. The plant did not operate in isolation. It functioned as part of a vast, synchronized system that converted raw materials into combat capability. Steel left the furnaces and entered history in the form of ships that crossed oceans and weapons that determined outcomes on distant fronts. When the war ended, production gradually slowed, but the transformation left permanent marks. Equipment was worn, workers were exhausted, and facilities had been pushed beyond peacetime limits. The war had proven Bethlehem Steel's capacity for maximum output, but it had also exposed the cost of sustaining such intensity. This period represented the company's highest level of influence and demand. Never again would Bethlehem Steel operate under conditions where national survival depended so directly on its furnaces remaining lit. The war years stood apart as a moment when industrial power translated immediately into military strength, and Bethlehem Steel stood at the center of that equation. Chapter 6. Life inside the plant. For the men and women who worked at Bethlehem Steel, the factory was not simply a place of employment. It functioned as a closed industrial environment that shaped daily routines, social relationships, and personal risk. Life inside the plant followed its own rules, rhythms, and consequences, largely disconnected from the world beyond the gates. The workforce was built primarily from immigrant labor. Throughout the late 19th and early 20th centuries, Bethlehem Steel recruited workers from Eastern and Southern Europe, including Slovakia, Hungary, Poland, Italy, and Ukraine. Many arrived with limited English skills and few employment alternatives. The plant offered steady wages, but at the cost of physical danger and long hours. Jobs were assigned based on immediate need rather than long-term stability, and workers often learned tasks through observation rather than formal instruction. Inside the plant, labor was strictly hierarchical. Foremen controlled job assignments, shift changes, and disciplinary actions. Advancement depended less on skill than on endurance and compliance. Workers were expected to maintain output regardless of heat, noise, or fatigue. Furnaces radiated extreme temperatures, while rolling mills exposed workers to heavy moving equipment with minimal protective barriers. Safety standards existed, but enforcement was inconsistent, especially during periods of high demand. Industrial accidents were common. Burns, crushed limbs, and fatal falls occurred with regularity. Molten steel splashes could cause severe injury in seconds, and mechanical failures often had immediate consequences. Injuries were frequently treated on site, and many workers returned to their stations before fully recovering. Fatal incidents were not rare, but they were rarely discussed publicly. Within the plant, accidents were treated as occupational risks rather than systemic failures. Discipline was enforced through a combination of surveillance and penalty. Absenteeism, slow output, or insubordination could result in reassignment to more dangerous positions or termination. Written rules governed behavior, but enforcement often depended on individual supervisors. This created an environment where caution and silence were strategies for survival. Complaints were discouraged, and grievances were typically resolved internally, if at all. Unionization emerged as a response to these conditions. Early attempts to organize were met with resistance from management, including firings and blacklisting. Over time, however, national labor movements gained influence, and unions became more difficult to suppress. Collective bargaining introduced standardized wages, defined shifts, and formal safety demands. These changes did not eliminate danger, but they altered the balance of power within the plant. Even with union presence, the factory maintained control over much of workers' lives. Shifts dictated sleep patterns, meal times, and family schedules. Overtime was common and often mandatory during peak production periods. Social life revolved around co-workers, many of whom lived in nearby company-built housing. Neighborhoods formed along ethnic lines, reinforcing cultural identity while also isolating communities from one another. The plant provided more than employment. It influenced access to healthcare, housing stability, and local commerce. Paychecks supported entire families, and layoffs could destabilize entire neighborhoods. For many workers, leaving Bethlehem Steel was not a practical option. Skills developed inside the plant did not always transfer easily to other industries, reinforcing dependence on the factory. Inside the gates, time felt compressed and repetitive. The same tasks were performed shift after shift, year after year. Noise levels made conversation difficult, and communication relied on gestures and routine. The physical environment demanded constant attention, leaving little space for reflection or distraction. Work was not just labor, it was a continuous state of alertness. This enclosed industrial world produced a workforce defined by endurance rather than comfort. Pride existed, but it was rooted in survival and shared hardship rather than prestige. Workers understood that the steel they produced shaped the nation, but their daily experience was measured in hours endured and injuries avoided. When production later declined and the furnaces shut down, many former workers described a sense of dislocation. The factory had structured their lives so completely that its absence created a void. Bethlehem Steel had been more than an employer. It had been the environment in which entire generations learned how to work, endure, and coexist under pressure. Chapter 7. The First Cracks. By the late 1950s, Bethlehem Steel still appeared powerful from the outside. Its name remained associated with American industry, and its facilities continued to operate at massive scale. Yet beneath this surface, structural weaknesses had begun to form. These weaknesses did not emerge suddenly, nor were they caused by a single event. They developed gradually, through decisions that favored continuity over adaptation. One of the earliest and most critical issues was technological stagnation. Bethlehem Steel relied heavily on traditional blast furnace operations that had served the company well for decades. While these furnaces were capable of producing large volumes of steel, they were energy-intensive, labor-heavy, and increasingly inefficient compared to newer methods being adopted elsewhere. Overseas producers, particularly in Europe and later Japan, began transitioning to basic oxygen furnaces and continuous casting technologies, which reduced production time, energy consumption, and waste. Bethlehem Steel was slow to adopt these innovations. Management viewed existing infrastructure as proven and reliable, and modernization was seen as a disruption rather than a necessity. Retrofitting aging plants required large capital investments and temporary shutdowns, both of which were perceived as risks. As a result, upgrades were postponed, and older equipment remained in service well beyond its optimal lifespan. This hesitation created a widening gap in productivity. While competitors were producing steel faster and with fewer workers, Bethlehem Steel continued to depend on labor-intensive processes. Output per worker declined relative to global benchmarks, even as wage expectations rose. What had once been a strength, the ability to operate enormous integrated mills, began to turn into a liability. Costs escalated across multiple fronts. Aging machinery required frequent maintenance and repairs, increasing downtime and expense. Energy consumption rose as older furnaces demanded more fuel to achieve the same output. Environmental regulations introduced additional compliance costs, which were more burdensome for outdated facilities than for modernized plants designed with efficiency in mind. Labor costs also increased. Decades of collective bargaining had secured higher wages, benefits, and pensions for workers. These agreements reflected the company's earlier profitability, but became harder to sustain as margins tightened. Unlike newer competitors operating smaller, more flexible mini-mills, Bethlehem Steel carried the financial weight of a large, established workforce and long-term obligations. Capital allocation decisions compounded the problem. Instead of aggressively reinvesting in core steelmaking technology, Bethlehem Steel diversified into unrelated industries, including shipbuilding and mining ventures that failed to deliver expected returns. These investments drained resources that might have been used to modernize primary operations. As profits were spread thin, modernization remained incomplete or delayed. The company's size further limited its ability to respond quickly. Large integrated plants were designed for stability, not agility. Shifting production methods or scaling output required complex coordination and long lead times. In contrast, emerging competitors could adapt more rapidly to changes in demand and pricing. By the 1970s, these issues began to affect competitiveness directly. Bethlehem Steel's production costs exceeded those of foreign producers, even before accounting for transportation. Imported steel entered the American market at lower prices, exposing inefficiencies that had been masked during periods of high domestic demand. The first cracks were not dramatic. There were no sudden closures or public admissions of decline. Instead, warning signs appeared in financial reports, delayed upgrades, and shrinking profit margins. The company continued to operate, but its strategic position weakened year by year. These early failures were not the result of ignorance. Information about new technologies and global competition was widely available. The problem lay in institutional inertia. Bethlehem Steel had been built to dominate a world where scale alone guaranteed success. When that world changed, the company struggled to adjust its assumptions. By the time the severity of these issues became impossible to ignore, the cost of correction had grown substantially. Modernization was no longer a matter of improvement, but of survival. The cracks that formed during this period would later expand into fractures that reshaped the entire American steel industry. Chapter 8: Losing the Steel War. By the late 1970s, Bethlehem Steel was no longer competing solely with other American producers. The battlefield had expanded beyond national borders. Steel had become a global commodity, and price, efficiency, and flexibility now mattered more than tradition or scale. In this new environment, Bethlehem Steel found itself at a disadvantage. Imported steel began entering the United States in large volumes. Producers in Japan, South Korea, and Western Europe operated newer facilities built after World War II. Referred to, often with modern equipment and lower per-ton production costs. These companies could sell steel in the American market at prices Bethlehem Steel struggled to match even before accounting for transportation. Import penetration steadily increased, eroding domestic market stability. Government trade protections offered limited relief. Tariffs and quotas were introduced intermittently, but they could not reverse the underlying cost imbalance. Imported steel remained competitive, especially for standardized products where price outweighed brand familiarity. Customers who had once relied almost exclusively on domestic suppliers began diversifying their sources. At the same time, a new form of competition emerged from within the United States itself. Mini mills, using electric arc furnaces, operated on a fundamentally different model. Instead of massive integrated plants, they relied on smaller facilities, scrap metal input, and streamlined labor structures. These mills required less capital, fewer workers, and could be built closer to end users, reducing transportation costs. Mini mills focused initially on lower-grade steel products, but their technology improved rapidly. As quality increased, they moved into markets traditionally dominated by companies like Bethlehem Steel. Their flexibility allowed them to adjust output quickly in response to demand, something large integrated producers struggled to do. Globalization intensified these pressures. Advances in shipping, logistics, and international trade coordination made steel a truly global product. Buyers compared prices across continents rather than regions. Long-term supply contracts gave way to competitive bidding, placing additional downward pressure on margins. Bethlehem Steel's cost structure proved incompatible with this new reality. High fixed costs, legacy pension obligations, and aging infrastructure limited pricing flexibility. Even when demand rose, profits remained constrained. When demand fell, losses mounted rapidly. Market share declined steadily. Industries that once depended heavily on Bethlehem Steel, automotive, construction, and heavy manufacturing, sourced increasing portions of their steel elsewhere. The company retained certain specialized contracts, but these could not offset losses in high-volume segments. Attempts to respond were fragmented. Bethlehem Steel closed some facilities, reduced its workforce, and sought efficiency improvements, but these measures addressed symptoms rather than structural disadvantages. The company could not shrink fast enough to match falling demand, nor modernize quickly enough to regain cost competitiveness. By the 1980s, the phrase "steel war" no longer referred to rivalry between American giants. It described a struggle between industrial models, large integrated mills built for mid-century dominance versus lean, modern producers optimized for a globalized economy. Bethlehem Steel was firmly rooted in the former. Losses accumulated, and confidence eroded. Investors, customers, and employees recognized that the company's position had fundamentally changed. Bethlehem Steel was no longer setting prices or standards. It was reacting to forces it did not control. The defeat was not sudden. There was no single year of collapse or decisive blow. Instead, market share slipped incrementally as competitors captured opportunities Bethlehem Steel could not. By the time the trend became undeniable, reversing it would have required resources and structural changes beyond the company's reach. This period marked the point at which decline became irreversible. Bethlehem Steel had not simply lost contracts or customers, it had lost the strategic ground on which it had once dominated. The global steel market moved forward, and the company was left struggling to keep pace. Chapter 9. When the furnaces went silent. By the mid-1990s, Bethlehem Steel's decline had reached its final stage. Years of shrinking market share, rising costs, and failed restructuring efforts had exhausted the company's ability to sustain large-scale steel making. In 1995, steel production at the Bethlehem, Pennsylvania plant officially ceased. The blast furnaces that had operated for nearly a century were shut down, ending an era that had defined both the company and the city that carried its name. The shutdown was not abrupt, but it was decisive. Operations slowed, contracts expired, and furnaces were taken offline one by one. When production finally stopped, there was no replacement plan. The plant did not transition to a new function or modernized process. Steelmaking simply ended. What remained were idle structures, cold machinery, and a workforce with no immediate future. Mass layoffs followed. Thousands of workers lost their jobs over a short period of time. Many had spent decades inside the plant, performing specialized tasks that were not easily transferable to other industries. The skills that once secured stable employment became difficult to monetize in a region where heavy industry was disappearing altogether. The economic impact extended beyond the plant gates. Bethlehem had grown around the steelworks, and its local economy was deeply dependent on the wages it generated. As paychecks vanished, local businesses struggled to survive. Shops closed, property values declined, and municipal tax revenue dropped. Services that relied on industrial prosperity faced funding shortfalls, compounding the city's difficulties. Social consequences followed economic collapse. Families relocated in search of work, accelerating population decline. Those who remained faced reduced opportunities and a changing identity. The city that had once been associated with production and stability became defined by absence. The massive plant, visible from nearly every part of Bethlehem, stood as a constant reminder of what had been lost. For Bethlehem Steel as a corporation, the shutdown marked a critical turning point. Without its flagship operations, the company's remaining assets could not generate sufficient revenue to meet financial obligations. Debt accumulated, pension liabilities remained unresolved, and restructuring efforts failed to restore profitability. In 2001, Bethlehem Steel filed for bankruptcy protection. The filing confirmed what years of decline had already suggested. The company could no longer function as an independent steel producer. Bankruptcy proceedings focused on asset liquidation and debt resolution rather than recovery. Steelmaking was no longer central to the company's future. The bankruptcy had lasting consequences for former employees. Pension benefits were reduced or transferred to federal insurance programs, often at lower levels than originally promised. Healthcare coverage was curtailed. For many retirees, financial security deteriorated after years of reliance on company commitments. By the early 2000s, Bethlehem Steel effectively ceased to exist as an operating industrial entity. Assets were sold, subsidiaries were dissolved, and the corporate structure was dismantled. What had once been one of the most powerful steel producers in the world was reduced to a legal process and a collection of abandoned facilities. The silence of the furnaces carried symbolic weight. For generations, the sound and glow of steelmaking had signaled continuity and purpose. Their absence marked not only the end of production, but the end of a way of life structured around industrial certainty. Bethlehem's experience was not unique, but it was emblematic. The closure illustrated the consequences of structural decline in heavy industry and the vulnerability of cities built around a single economic engine. When that engine stopped, there was no immediate replacement. The plant's closure did not erase its physical presence. Rusting structures remained along the Lehigh River, dominating the landscape even as they served no economic function. They stood as evidence of scale without use, capacity without demand. This chapter represented the point of no return. Production had ended, jobs were gone, and bankruptcy formalized the collapse. What followed would not be a continuation of steelmaking, but an attempt to reinterpret what remained. The furnaces were silent, and the era they represented was over. Chapter 10: Bankruptcy and What Remains. After bankruptcy proceedings began in 2001, Bethlehem Steel entered its final phase not as a producer, but as a legal and financial entity being dismantled. The company no longer operated blast furnaces, rolling mills, or finishing lines. What remained was the process of liquidation. In 2003, Bethlehem Steel Corporation was formally dissolved. Its assets were sold, its subsidiaries absorbed or shut down, and its name ceased to exist as an independent industrial force. The dissolution marked the definitive end of Bethlehem Steel as a functioning company. There was no reorganization aimed at revival, no return to production under a new structure. Creditors were prioritized, properties were transferred, and intellectual ownership was settled. The corporation that had once supplied steel for bridges, railroads, skyscrapers, and warships was reduced to contracts, deeds, and court filings. For former employees, the dissolution finalized losses that had already been felt for years. Pension responsibilities were transferred to federal insurance programs, often at reduced levels. Healthcare benefits were curtailed or eliminated. Promises made during decades of employment were revised by necessity rather than choice. The end was administrative, but its effects were deeply personal. The physical remains of Bethlehem Steel outlasted the corporation itself. Along the Lehigh River, massive blast furnaces, ore bridges, and stacks remained standing long after production stopped. These structures were not immediately removed, partly due to their scale and cost, and partly because of their symbolic weight. They dominated the skyline, silent reminders of industrial capacity without function. Rather than demolish the entire site, stagnation, portions of the former plant were eventually repurposed. The most visible transformation became steel stacks, a cultural and arts complex built within and around the preserved blast furnaces. Concert venues, performance spaces, and public gathering areas were integrated into the existing industrial framework. The furnaces were stabilized, not erased. Steel stacks did not attempt to recreate the factory's original purpose. It acknowledged that steelmaking would not return. Instead, it preserved the structures as historical artifacts, allowing the public to occupy spaces once defined by heat, noise, and risk. The furnaces became backdrops rather than tools, shifting from production to remembrance. This transformation reflected a broader change in how industrial heritage was understood. Bethlehem Steel's legacy could no longer be measured in output or employment. It was measured in impact on the city, on generations of workers, and on the built environment of the nation. Preservation replaced operation, and interpretation replaced manufacturing. The city of Bethlehem continued to adapt around what remained. Redevelopment efforts focused on diversification rather than industrial replacement. Education, healthcare, tourism, and cultural events gradually filled portions of the economic void left by the plant's closure. The transition was uneven and slow, but it reflected acceptance that the industrial era had ended. Memory played a central role in this final chapter. For former workers, the site carried personal histories of labor, injury, pride, and endurance. For newer generations, it represented a past they did not experience, but inherited through stories and physical presence. The The furnaces became reference points for identity rather than employment. Bethlehem Steel's legacy is not preserved in a single narrative. It exists simultaneously as achievement and failure, as strength and rigidity. The company helped build modern America, yet could not survive the forces that reshaped global industry. Its collapse was not a moral judgment, but a consequence of structural change. The dissolution in 2003 closed the corporate record, but it did not erase the company's imprint. Steel produced decades earlier continues to support bridges, buildings, and rail lines across the country. The physical environment still bears its mark, even where its name is no longer spoken. What remains of Bethlehem Steel is not a functioning factory nor a revived brand. It is a landscape of preserved structures, altered purposes, and layered memory. The furnaces stand without fire, the mills without motion. They do not promise a return. They mark an ending. In that silence, Bethlehem Steel's story concludes not with renewal, but with endurance of another kind. The company no longer produces steel, but its presence persists, in infrastructure still standing, in a city reshaped by loss, and in an industrial skeleton left deliberately visible. The steel is no longer being made, but it has not disappeared.